Hey, Tuck, you're number one today, man. Welcome aboard. Happy Sunday. Adam, welcome. Nice to see you. Hey, you got a Form 3 Plus. Cool. I have a lot of tricks to show you. So if somebody on the YouTubes can tell me we're doing okay, I'll take off the standby sign. Ugly, welcome aboard. Danny, welcome aboard. Justin, welcome aboard. Marks. We got a Mark and a Marks. I will. And you know, you have the hotline. Oh, okay. I have evidence that YouTube is good. We are no longer in standby. Carl, welcome aboard. Brian Tools, welcome aboard. Hey, happy Sunday. Michael, welcome aboard. So if you're wondering what the heck's going on here, you came to the right place. This is the PFG Live. There are a lot of lives, but this one is PFG. And we're going to talk about Chris, mostly. Welcome aboard, Chris. Prodium, welcome aboard, sir. You guys are awesome. And let's see, Wes is in the YouTubes. Welcome aboard, Wes. So I know you know this, but I'm going to tell you anyway. This is simultaneously streamed live on YouTube and on Instagram. So you could join on either one. However, in the future, there will be some YouTube-only events. So I would suggest you just get used to coming in on the YouTube side, just so you know how to do it. Deflagrate, welcome aboard. And anyway, so yeah, see if you can get your YouTube foo up and join us on that side. Meanwhile, everything's going great. We have some things to review from the last live. Brian is playing with both hands now. James Howe, welcome aboard. We're going to go over the stuff we talked about last live about heat treating. I have some exciting results. I have an exciting failure and an exciting success. Almost, I wouldn't give myself 100% on the success, but I'd give myself about an 89. And we'll talk about that. Plus, I got restocked on heat treating envelopes or pouches or containers, depending on who you are. I'll show you. Fresh, unopened. I think I got 40 more of these guys. They're the perfect size for the oven, so I figured, what the heck. There's the address. You guys on YouTube have no problem capturing that. The Century Company in Foxborough, Mass. First of all, I love these guys, okay? And they're local, relatively local. Alphonse, welcome aboard. So one of the reasons I love them is you could still fax in your order. So you go to the website, and you could look at the website when you want to order something. There's an order button. So you hit the order button, and it has you fill out a form, which is basically an email to the company. VacPack, exactly right. VacPack. And then you get an email back saying, well, please fax us your order or call us with your order. It's just, they're almost there. They're this close to being in the 21st century. But it doesn't matter. They're super good people. And there you go. And I think we finally got the hang of running these things so that they're coming out quite nice. Certainly as far as oxidation is concerned, I think I'm very happy with what's been going on. So I have some show and tell in that department. We're going to talk about ground chuck, not hamburgers, but hamburgers are a good idea today because one of our guys. Sorry, I'm having a brain fart here on his username, but it'll come back to me. He went to grind his chuck and had some difficulties, and he did a couple of things wrong on the first go around. Then he cleaned up his procedure, and things started happening. Hey, Warren, welcome aboard. Are you back from the great north of Maine? Warren was doing things up in the Maine, up the coast. And then finally, we're going to talk about chromoflatosity. You're not going to want to miss this. Well, welcome aboard, sir. Happy Sunday to you. And if any of you guys have questions, you could, if you have them already in your head, you could dump them into the chat and or on Instagram, the question box. And we'll get to them today. Yeah. So, anyway, that's what's going on. So let's get it. Oh, and a reminder, and we'll put this reminder at the beginning, and we'll put this reminder at the end. And the reminder is that the contest is still going on. Mr. Gross, welcome aboard. If you want to join in on the contest, the details are at pfg.gg/contest or pfgstones.com/contest. And it's pretty simple. Go over to YouTube, watch the video called Perfectly Figured Guesses. It'll explain the contest, it'll actually give you information you need. Read the description on the video. It has more information you need. And the rules are also published. So make a guess as to how many boxes are in the bag. If that doesn't make sense, it'll make sense later. And if you're the closest one and or the first one with the right number, you win a set of 6-inch PFG stones. Laser marked with your personalization that you will supply to me, and a lid. And these can be yours. So we'll be talking more about that later, but I just wanted to get that out because the contest is starting to build steam. Hey, so I see joining us is Lynn Jing with a 75 in the middle. Hi, Lynn. What's your interest in our channel today? You could just put that in the chat. Let me know. Okay, so let's get started. Last week, oh, by the way, I was traveling all week, so I was not in the shop. So I didn't get as much done as I wanted. The grinder is warming up right now. Hey, Junkyard, welcome aboard. The grinder is warming up right now. I might grind some of these parts I'm about to show you. So I don't know if I'm going to do the whole job, but I'm really itching to put a wheel to a piece of steel. So we are going to do that. All right, so last week we talked about Chris's project. And Chris has a project that we are making for him. It's a gauge for his work. And for all practical purposes, let's just call it a 6-inch straight edge. But a good straight edge. So it's going to be hardened. It's going to be accurate. It's going to be flat. And it's going to be what Chris wants, which is the important thing. So this is the raw stock. This is the raw stock for that. This is A2 tool steel. It's 1 inch wide, 1/8 inch thick, and 6 inches long, and all of those numbers are oversized. So we have yeah, had enough of that. So it's oversized, so we have enough for grinding, we have enough for finishing. So we start with that, and then we heat treat it. So we stick it into an envelope, one of these beautiful envelopes that start out all shiny inside and out, and then we end up with the pouch envelope container looking like this. By the way, for extra credit today, does anybody know the alloy of stainless steel that that these pouches are made out of? You get a free sticker pack. Right, so Chris just told us in... let me get the drawing. Is it okay if I show the drawing, Chris? 303 is incorrect. In fact, 303 is very incorrect for an interesting reason. By the way, I haven't had to... Okay, thanks. I haven't had to block somebody on Instagram in a very long time, you know, on the live, but I just did it. And it was one of these phishing attacks from somewhere, you know, where you get a message from a scantily dressed person. 304 is incorrect. And by the way, Wes, just going up incrementally is not fair, okay? I'm kidding. So I'm going to show Chris's drawing here. It's pretty simple. There's actually a couple of features that aren't on the drawing yet. But it's got a bevel to it. It's going to be ground and flat and wonderful. And if you look on the drawing, where is it? We specify the width, but Chris is saying that width is not super critical, and the length isn't super critical. We know that. What's super critical is straight, flat, all the stuff associated with a handheld gauge. And of course it says, I don't know if you could read it, it says Laser Shark typical. So we'll have a Laser Shark involved. So the idea is we're going to so Wes says we use 304 for exhaust flanges. Very interesting. Your choice for exhaust flanges is probably better than this alloy, and I'll explain that in a second. Hey, Matthew. So we take the blank, we cut it to length, we by hand we just dress the edges so they're not super sharp, there's no burrs, and now we go into heat treat. Ding, 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 ding. We have a winner. So coming from a weak start, Warren, who originally said 303, comes in and he says, okay, 309 or 321, depending on temperature. The answer is 309, and that is correct. Now, okay, well, Brian admits that he cheated, but he did come in with the right answer, 309. Correct. But Warren came in with it. It's 309. And the interesting question is why. Now, I'll tell you another thing that's made out of 309 stainless, and that is my Rolex. When I did a little research, it's like that's what they use. I don't know why, but it has something to do with they forge it and then they machine it, etc., etc. It's kind of weird. But 303 is free machining stainless, and to make it free machining, yes, Chris is correct. We'll get to that. The thing that makes 303 free machining is, I believe, sulfur. I might be wrong on that. but there's an added thing to the mix to make it free machining, and really that's not what we're interested in. 304 is used for exhaust flanges because it's not going to oxidize when it gets hot, but we want it to oxidize when it gets hot. So Chris correctly points out that it's because it consumes oxygen. Correct. Okay. All right, K-Bonk. So 309, I'm no metallurgist, reacts with the oxygen at a reasonably low temperature, which in some cases you don't want to have happen. I guess in the case of a watch, in the example of a watch case, it's never getting up to that temperature, so that's a non-issue. But look at the outside of the envelope and look at the inside of the envelope. Okay, and you could tell that the outside got very, very oxidized, whereas the inside got a little oxidized. So what that does is the 309 stainless reacts with the oxygen at an elevated temperature. I don't know what the magic temperature is when it kicks off, and it will react with the oxygen on the inside, which is why it's not shiny anymore. Okay, and it's a little dark, it's a little gray, but the outside is really black. So once the oxygen gets consumed in the bag, no, 300s are not magnetic. 400s are magnetic, but let's see. Maybe I'm wrong. I'm getting nothing there, bud. So the oxygen gets consumed in the bag, which is desirable to keep it off your part. So if the 309 stainless reacts with oxygen at a temperature that's lower than your workpiece, life is good and everything's hunky-dory, and your piece does not get any oxidation. So when we go to package up the part, I did an experiment. I published this on YouTube, so some of you already know that. You see the white powder in there? Okay. Traditionally, and I talked to Grimsmo about this, traditionally knife makers use talc as one of their herbs and spices to prevent sticking of blade to envelope. Oh, Carl, you make me so happy when you say words like that. Carl says, you're saying that the foil pouch is functioning as a getter. Yes. And you're showing our age. So a getter, ooh, I'd have to, maybe next week I'll show a vacuum tube. A getter is a thing that is there to scavenge gas. That's its job in life. And in vacuum tubes, back, when dinosaurs roamed the earth, vacuum tubes were manufactured with a getter in them. And as part of the manufacturing process, the getter would be heated or held to very high voltage or something, and it would then suck up the last 17 and a half molecules of gas inside the vacuum tube. And that's called a getter. Hey, DSIM.mx, welcome aboard. And I don't know how to pronounce your name. We're going to call you Basan. Bastian. Well, welcome. So you're 10 years older than me. Okay, so you're right in there. I have some cool vacuum tubes downstairs. We'll have to put it on the list. But so we figured out the pouch, right? And somebody said something really cool to me. I don't remember who it is. If you're in here, raise your hand. And they said, thank you for explaining that the pouch or the envelope or the container is an active part of the process, not a passive part of the process. Yeah, it's an active part of the process. I don't have any big transmitter tubes, Carl, but I have a lot of receiving tubes, and I have a logic tube from the days of vacuum tube computers. Another day. We got to move on here, or we'll be here all day, which I'm not I'm not adverse to. So you've figured out how to put your stock in a pouch and fold up the top, and you fold it up 3 times. You fold it up, you rub it, you fold it up, you rub it, you fold it up, you rub it, and it's gas tight. So talcum powder is used by knife makers as an anti-stick, because if you take a super clean blade and you put it in a super clean envelope and you bring it up to temperature, things stick together. Now, on my last batch, you may recall, I'm sorry, 2 batches ago, batch number 1, I was a real novice and neophyte and idiot, and I put all of my parts together in one pouch, and they stuck together like you wouldn't believe. Don't rub with finger. Oh, you mean the pouch or the skin oils? So, in order to prevent sticking, part to part, part to pouch, you use something. I don't have any talc, so I did a little research, and it turns out that you could buy talc. You can go down to the drugstore, you know, your CVS or whatever, and buy talcum powder. But you got to be careful, because the additional ingredients may be bad for your process, and you can easily accidentally buy a cornstarch-based baby powder. Also, not where you're going. So here I am. Necessity is the mother of invention. A corollary to that is invention is a mother. Hey, STG, welcome aboard. So I said, well, what do I have that I could use as talc? Or where could I get talc? That was the first round. So I got on McMaster-Carr, and yes, you can absolutely get talc, pure talc from... Actually, no, I started with Amazon. I can get it on Amazon. I started going to McMaster-Carr. And then I remembered I have 5-micron aluminum oxide lapping grains, which is the term of art. And that's sort of like talcum powder. I reasoned that it's the mechanical behavior, not a chemical behavior, that is doing its job as an anti-stick. So I went down to the basement, and I got myself, I think I showed you this last week, I got myself some some aluminum oxide powder, 5-micron, okay? And proceeded to take a little tray and an acid brush. You see the acid brush in there? It's kind of bright. And I am here to tell you that 5-micron aluminum oxide grains acts just like confectioner's sugar. Okay, so if you've ever had a powdered donut, you've had confectioner's sugar. Well, the feel and behavior of this stuff is exactly like confectioner's sugar, except it's not going to dissolve because it's aluminum oxide. And this sounded really good to me, so I went ahead and I using the brush, I painted my parts. Dry. I just took the powder on the brush and painted the parts, and it stuck to the parts. And I put some in the pouch, and it sticks in the pouch. You see it? And I went ahead with my process. The second thing I did with the second batch, the first batch being a disaster, right? Here's the first batch, okay? And they came out not flat because I had to rip them apart with force while they were hot, and it was just not good. By the way, the yield on batch number 1 was 2 pieces out of 5. are acceptable to go to the next step. So, oh, and one other thing about batch number 1 is that I did rip the parts out of the bag and I air quenched them, still air, but I air quenched them out of the bag. You have to know that for a punchline coming up here. When batch number 2 parts came out, okay, here's batch 1, here's batch 2. Look at the color. Look at the absence of color, because I left them in the pouches and I air quenched them in the pouches. I did this because I reasoned that the pouch didn't represent much of an impediment to the thermal impedance to the air. Minor error there coming up. And did it work? Yes, it worked. The oxidation was absolutely minimal. There's a teeny bit of color on there, but more importantly, I put these in one envelope per part or per blade, and that helped. The flatness of them is very good. It's not perfect, but it is easily 10 times or more better than what I had before. And then I went ahead and I did hardness testing. So this was an interesting discovery. When I hardness tested batch 1, I came up with Rockwell C59, okay, which, by the way, was pretty much dead on to what the numbers should have given us. It was a 450 degree Fahrenheit temper. Hey, Jake. 450 Fahrenheit temper, and if you look it up in the book, it says 58 to 60, and 59 is right in the middle. It's like, okay, awesome. Batch number 2 was very interesting, okay? And I'll be making a video. I've been saving all the little snippets, video snippets, and I'll put it all together for you. But batch number 2 came out really nice in a still air in envelope quench with the envelope sitting so that these guys were like that, okay? I took this is my rapid response roast tray turned cooling rack, okay? I flipped it over, I put it up on a couple of fire bricks, and I used it like a file folder rack, and I put my parts in the envelopes in the rack. So there was like 3 inches under them, and of course open air around them. I did not use a fan. Now, Robin Renzetti said, "Where's your fan?" And I respect that, but I specifically wanted to keep apples and apples from the last batch, so I didn't make any changes there. The result being that the hardness test on batch number 2 came in a little lower. Not screaming lower, but on the order of 1 point lower, thereabouts. So they were coming in around 57. Like here's a couple of tests at 56. And then, of course, there's a test here at 58. This one had a bit of a spread. I don't know why. But on average, they came in a little lower. So my hypothesis is that the quenching them in the envelope in still air was enough to slow down the quench and cost me hardness in the end. Theory, okay? I mean hypothesis. So the next batch I want to do almost everything the same, but there's a couple of things I want to do different. Number 1 is I want to put 2 parts in a pouch as an experiment for the aluminum oxide anti-stick. I'm not too excited about that because I sort of settled on 1 part per pouch, and that's it. But I might do that experiment. I might not. But the second thing is I want to put a fan on it. So Robin says, where's your fan? I remember somebody on YouTube talking about A2 heat treating using a fan that was not like super high volume, but just on low, just a gentle movement of air in the quenching area. And I don't remember who did it, but that's what I want to do. So I'm going to set up a fan, have a very gentle flow of air. I don't want to have any asymmetrical cooling that might cause some warping. I don't want warping. And then we're going to try this whole thing again. So all in all, I'm very pleased with the results of the heat treat, the performance of the pouches or the containers or the envelopes, and the performance of aluminum oxide 5 micron as an anti-stick. In fact, I am going to make a bold statement that it might be better than talc. I can't come up with a reason why it's worse than talc. The only thing I can come up with is if for some reason you think it's not going to scratch, the talc won't scratch steel, but the aluminum oxide will scratch steel. Of course, at 5 micron, it's not doing much. I will admit that the surface behavior after heat treating with the talc as an anti-stick, all the shininess went away, but we don't care about that. K-Bonk says, I wonder if the ambient air temperature matters. Yeah, actually, theoretically it matters because it will affect the rate that it comes down. So, yeah, but I think the thermal impedance from the hot part to the atmosphere is lowered by the fan. It's lowered by the absence of foil, right? And it's lowered by... Can you make that argument? No, you can't make that argument. So those things are going to impact the rate of cooling. So, the way you learn is through failure, and I had some really good failures here. So that's why I said I'd give myself about an 89 on this, because I think we lost a little bit of hardness because of the quenching rate. They both got the same tempering, which was 450 for several hours. So that doesn't explain it. Carl says, I think you have to do the experiment. Too many variables to predict Alox versus talc a priori. Yes, I totally agree. I'm hoping I could snag some knife makers into joining that experiment. And I think I know one knife maker. I'm gonna yank his chain and see if he's willing to do it. But I'm a big fan. I'm a big fan. So we'll see what happens. So we have sufficient stock to continue on Chris's gauge project, and that's good. So the experiments will continue. Chris's gauge project will continue, and I did get a book. One of you recommended Knife Engineering, and I got it. So good old Amazon. Picked it up. It's got a lot of good stuff in it. And I have not started reading it yet. So maybe the answer to some of our questions is in here. But I will report back to you. So at this point, I'll take any questions that you might have, because I'm going to have a sip of tea. And if you want to put something in the chat, I will be happy to answer it. Yes, Grimsmo is who I meant when I was making my inelegant sideways implication. And his blades are a stainless. Yes, they're not A2. So that would be another variable. But I know he uses talc, and because he's shown it on video and we talked about it. No secrets there. So it'd be interesting if he tried at least a couple of pouches with this, and I'm going to talk to him about it. Okay? So, the topic is, I'm going to do a quick look up here for a piece of information, and then we're going to talk about grinding the chuck. So, give me 1 second. I'm seeing if I got a message from someone. No, did not. Okay, so last week, Bart Harkema was bringing up his grinder that he's been working on, and he got to the point where he needed to grind the table and grind the chuck. Oh, we have some questions. Sorry. How did you figure out some are corn-based talc? It's not corn-based talc. It's talc, which is a mineral, and corn starch is used in some of those products. So if you go to the drugstore to buy talc for your heat treating, read the label. That was the message. And there are some products that have no talc in them. They are only a cornstarch. Read the label. Cornstarch will make a mess. I think cornstarch will melt and just make a mess. Brian says, okay. Brian wants to know about molybdenum dressing stick. May have a piece. Where to get otherwise. Okay, so let's talk about that. I bought, there's a company, I think they're up in Maine, that makes the molybdenum products. Okay, and I bought, I think I bought a 4 foot. No, I must have bought a 6 foot length of 99.5% molybdenum. I have to tell you, this was not cheap. So, if you guys are interested, I've been thinking about this. I can stock this. And we'll figure out a length to cut it to, and this could be part of our product. So if you want that, you have to let me know. And then the hockey puck that I made, again, there's no science to it. If that needs to be a product, let me know. But I will take it as homework to get you the name of that company. No, it's true. K-Bonk, Carl says, I think talc has suspected health issues for human use. Actually, it's true. I think that's one of the reasons they stopped using it. Moly Rod Company. So the problem with my supplier for Moly Rod is you're not going to buy a 6-inch piece. I had to spend, it was north of $400 for this piece. So I don't remember exactly how much. Just putting it back. So if you guys want me to be in the moly business, I can do that. That's not so hard. By the way, the 5 micron aluminum oxide being, again, just like confectioner's sugar, I don't think I want to be breathing it either. So you got to be a little careful with this stuff. But aluminum oxide it's as hard as aluminum oxide, as hard as your grinding wheel. It's not going anywhere. It's chemically doing nothing until you hit it with some ridiculous acid or some really high temperature, as Carl pointed out last week, over 2000 C. So it's pretty benign, but it is also pretty small, and you can get it into your lungs. So again, just be sensible. I will look up the moly rod supplier for you, and I'll get it back to you. Okay, Brian? All right. So Bart was grinding his chuck, and he had some problems. One of the things that happened was he was using a 60 grit wheel. It was a white wheel, which means it was a aluminum oxide. Oh, okay. So Brian says, I know we're jumping around. Just hang in here with us. Brian says he may have a piece of moly. How do I know? I don't know. That's why I label everything 3 times. Yeah. Carl says that he consulted for a company that used moly forging dyes in the 90s. It was over $100 a pound back then. Yep, non-magnetic. All right. We can get back to moly a little later. I want to get into this ground chuck topic. So he used a white wheel, aluminum oxide wheel, 60 grit, and his video, you should look up his video on Instagram. It was very instructive. He was getting squeaking out of it. I've never heard squeaking out of a grinding process. But it was very clearly indicative of wheel loading. And when the wheel loads, so what does wheel loading mean? It means that metal is, or whatever you're grinding, is getting into the pores of the wheel and removing any relief that the grain of the grit has behind it for swarf to go. So there's nowhere for swarf to go. So really it starts rubbing. This is exactly the same as every other cutting process. But what I'd never heard is I never heard the squeaking. It was squeaking. So it stopped cutting. This is a real problem with grinding chucks. So we talked on text, and I gave him, whatever tips I had, and that's kind of what I'm going to give you guys, is a little bit of a brain dump on grinding the chuck. Now, I've ground the chuck under a dozen times, so I wouldn't call that being an expert. But I learned early on some of the issues. So when I had my Harrig, which Ducky now has, I was trying everything, and I was starting from the back of the chuck, and I was grinding, and as I came to the front of the chuck, it was going up by 4/10, which doesn't sound like a lot, but it's a million miles in grinding. And if I put it, now listen to this next one, this is very important. If I put an indicator on the head and I swept it, I can see the whoop, I can see the ski hill toward me. Now remember, we said that an indicator on a grinder indicating the chuck or the work you just ground is only indicating the match between the position of the wheel and the ways. So if your ways are crazy, you're not going to see it. If you have a smile or a hump in your ways, it's not going to show you on the indicator. So putting that aside and assuming perfect ways, I was seeing in the y-axis this rise. Well, why would I see that? Well, I'm seeing that because as the wheel's going across the chuck and I'm stepping over toward my belly, okay, it stopped cutting. And because it stopped cutting, the chuck rose. So that was loading up. Now, if you look at a grinding wheel that's loading up, it might look a little gray, and that's it. Or it might look a little black, but that's it. It doesn't have, a whole bunch of packed chips in it that are obvious unless you're in a really bad place. So there were two things that are important. Three things. There are three things that are important for preventing this problem. Number one, you're grinding soft metals. Use the coarsest wheel you've got. Number two, use coolant always. The coolant does cooling, but it also helps prevent the metal from loading up the wheel. Okay, so coarse wheel, 46 grit is fine. Like a 46J is fine. Use coolant. Now, I didn't have coolant on the Harrig, and somewhere I learned that you could use Crisco. one of the good uses for Crisco. So I took Crisco and I put a thin layer of Crisco and I went to town. Other people report excellent results with WD-40. Same thing. Spray the chuck with WD-40 and go. The third thing is dress. A fast dress. So fast dress means you're going to it's actually truing, right? But it is dressing, and here's why. You're going quickly across the wheel with your diamond to leave. It's almost a thread in the wheel, right? It's almost like you're thread cutting. So it's got fingers. All of these things are because the material is so soft, and you need room for the swarf to go. You want to encourage it to not hang on to the wheel, and those are very important. Then I learned a trick from an old Norton publication. I can't find it. It's driving me nuts. If any of you guys find it, let me know. I will broadcast it to everybody. It was a little one-pager, how to grind your chuck. And it said, and this is what saved me on the Harrig, it said, use a step over of 1/2 your wheel width. So, when we work on the grinder, we're so used to wanting everything to be shiny and perfect and have no pattern to it. And then when we go to grind the chuck, we have the same approach. It's the wrong approach. We want flat. We do not care about surface finish. So I did that. The other rule, I left out one rule, is 1/10, maybe 2/10 maximum downfeed. That's it. And if you want to really guarantee success, 1/10. And I know what you're thinking. You say, well, this is going to take all day. Correct. So as soon as I followed all of those rules I just outlined for you, including the 1/10 and including the proper dress, but most importantly, the one that broke the ice for me was the half wheel step over. Boom, I got a dead flat chuck. Okay? The wheel did not have an opportunity to load up. Or if it was loading up, it didn't load up enough to stop cutting. And that was it. Fast forward now to the table is okay. So K-Bonk says, can I assume the same for the table as the chuck? The table, meaning the part of your grinder which holds the chuck. Okay, if you have an old grinder and you're redoing everything, grinding the table is a standard thing to do. The table has its own requirements, and I will pass them along now. I screwed up the table when I had my Micromaster. So I had my Brown and Sharp Micromaster, and I was going through the same process where I actually took the chuck off that it came with, and I set it aside, and I put a new chuck on it, a new used chuck. So I had to grind the table. I had a terrible time. I was burning the table. We'll get back to the magnet on off. It's on, by the way. The answer is on, magnet on. So after pulling my hair out, this relatively unknown guy on the internet called Robin Renzetti, he sent me a message and he said, smacked me upside the head and said, he didn't smack me upside the head. He's a nice guy. And he said, you should be using a silicon carbide wheel for the cast iron table. All right. So I fixed that. Ironically, the only silicon carbide wheel I had at the time was 100 grit. So after telling you all this about use a 46 grit on the chuck, because it's soft metal, this is now cast iron. I got away with it. And I did the same thing. I did a fast dress on it. It was magnificent. And it came out just great. I honestly do not remember if I did the coarse step over trick with the silicon carbide. But once it was in the region of something that behaves like real grinding, it really just started behaving. And I got a glorious result out of that. Flat as a filbert, great finish, and I was done with the table. Okay? It's the aluminum and the brass, all that soft metal that is really hard to grind. As soon as you get into some good steels, you're all set. So back to so basically that's how I got the chuck ground, and those rules applied to the bottom. So the bottom of the chuck that came with the machine was also a cast aluminum. So I used the same procedures. But the new chuck that I put on the Micromaster was a cast iron. So I used the cast iron rules on the bottom of the chuck. But then I flipped it over, did all the stuff. You flip the chuck over. Of course, you've hit these things with PFG stones, haven't you? Didn't you? And that tells you, it gives you information about what's going on. And oh, by the way, Herman Schmidt, we're going to go long today, guys. I'm just warning you ahead of time. Herman Schmidt recommends putting a belly in the bottom of your chuck. I'm not going to go into this. I didn't do it, but this is what they recommend. Hi, Fly CNC, welcome aboard. So you flip it over, you put your favorite oil, grease. Somebody said WD-40. Please don't use WD-40 anywhere in this process except as a cutting lube, okay? Some people use LPS-3. Some people use LPS-2. Some people use LPS-1. Some people use a magic mixture of anti-seize and kerosene, I think. Whatever you like to use, you put that between the table and the chuck, you put it down, and now you torque down your hold-down bolts. One of them to 15 pounds, one of them to 10 pounds. This has to do with thermal growth. So it actually is getting allowed to move under the 10-pound bolt and not allowed to move under the 15-pound bolt. Now you're ready to grind your chuck. And now you follow the rules we just talked about. Aluminum oxide, 46 grit, fast dress, no more than a tenth. Always use coolant, half the wheel step over. Okay? And that is how I succeeded in life and ground chuck. Are there any questions? So I've been through 3 grinders worth of grinding chucks, plus 1 spare chuck, which I sold, but I did grind it, and probably a couple of regrinds on various chucks. In fact, I'm ready to do this chuck again, and I'm going to video it. All right, so what is chromoflatosity? It's a thing I made up. Wes says, it's like a gremlin. So many rules. Yeah, it's exactly like a gremlin. So, there's in this diatribe about grinding chucks, you heard something interesting. You heard the chuck does not have to look good. It just has to be flat. And there's a little message in there. And that is that, you know, we could, if we pick up a gauge block and we look at the Carl, and we look at the side of a gauge block, it's a mirror, right? We could look at ourselves in the mirror, and it's got two properties. It's got flat and it's got smooth. Well, okay. Now we grind our chuck with that fast step over and we look at it and it's kind of like, nah, the surface finish isn't that good. Maybe even you see some lines, but when you run your indicator all over the place, it is flat. But it's not smooth. And then you could have a part which maybe somebody takes, you know, a polishing, you know, goes over to a polishing wheel and polishes it up. And now you go to measure it and it is not flat, but it is smooth. So what's the difference? And I thought about this. And the answer is the difference is a matter of wavelength. You knew it was coming back to antennas, right? So what do I mean? If we have a, do any of you have a granite surface plate in the shop? The granite surface plate, when the guy comes to regrind, you know, relap your granite surface plate with all his magic tools, they typically will leave it crowned by, I think 50 millionths is the magic number. It depends on the grade, right? So here's your, I'm going to use the graphic system today. Here's your surface plate, and really, they're gonna grind it so it has a hump in it. Now here's my question: how many maximums are there to the height of that? Answer: 1. It has one height maximum. Okay, so we could give this some fancy names. We could say that this curve is of first order. Actually, it would be second order, but it has one maximum. And we would say that this surface plate, as long as that value is good, we're done, right? And this thing can look like a mirror. It could look like the Hubble mirror, right? What if you had the same exact plate, except you measure it and it looks like this? How many height maximums are there? There's one there and there's one there. Is this flat? We no longer think of this as flat. Okay. Here's another one. We have a surface and it looks like this. How many current maximums does it have? Many. But this thing could be measured by you flatter than this thing. This is what your chuck could look like, and make great parts all day long, because your parts are bigger than the variations, whereas your parts put on this thing are going to be smaller than the variations. So the wavelength of the surface pattern here is a low wavelength. Okay, low wavelength. Don't panic about the Greek. Whereas this one the wavelength is very long and it's longer than your parts. That's bad. So flat has to do with the size of your parts compared to the wavelength of the surface pattern that exists. And there's always a surface pattern, right? And the longest wavelength that we could make is in excess of the surface. So what is chromoflatosity? Chromo meaning color, okay, or the frequency of the signal. And that's determining whether you're flat or not flat, rough or not rough. It's high frequency stuff we call roughness, and low frequency stuff we call flatness. So if we plot the spectrum of these two things, you know, and you just have a very low or no signal, right? And this is the frequency, which is equal to 1 over the wavelength. We call that a flat surface that might have a height variation. But if we have a whole bunch of high frequency noise in our spectrum, it looks like this, and we say, oh, that's a rough surface. Okay? And if it's and if it smells, as Carl pointed out, it's chromoflatulence, which is totally different. So if you start chasing roughness where you don't need to chase roughness, you're wasting your time. And if you chase flatness where you don't need to chase flatness, you're wasting your time. So I guess the punchline is every surface should be as flat as it needs to be and as smooth as it needs to be, but not more. Otherwise you're just tearing up $20 bills. Okay? So you're not shipping your grinding chuck, your mag chuck. Nobody's going to see it. Inspiration Metalworks, welcome aboard. You may be late, but we respect you. Nobody's ever going to see your grinder, your grinder chuck. Yeah, Carl says fit for purpose. Exactly. But they're going to see your parts. You know, I get this stock from California Tool Steel. By the way, a good supplier. I like these guys. And, you know, it might be a 32 finish, I think. It's okay. Do I look at it and go, "Meh, that's too rough"? No, I don't. It's great. It's awesome. Fit for purpose, exactly. So from this day hereforth, we're going to call it chromoflatosity. You know, what wavelength is your surface? What is the spatial wavelength of your surface? And there you go. And now I've achieved the goal of tying back antennas to grinding. And that's why we came. That's why we're here. I will take any questions you guys have and any suggestions for things that we should be doing next week. While you're thinking of questions, I will remind you of the contest, which is underway. It ends next week. It ends on the 30th, 1 week from today, midnight. So we will have a live next week, and that midnight is when the contest ends. pfgstones.com/contest or pfg.gg/contest will take you where you want to go. And all the rules are there. Or you could just go to the YouTube channel, which is, you know, if you're on YouTube, you're already there, Kinetic Precision NH, and find the video called Precisely Figured Guesses. And that's the video that also is required for you to be in the contest. Robin's here. Robin, welcome aboard. I'm going to assume, Robin, that you have not heard what has gone on in the last hour, but your name was used with great reverence. But welcome aboard. Oh, Tuck Garage just submitted an entry. Thank you, Dan. Welcome aboard. So today we went over round 2 of my experiments with A2 heat treating. We talked about Robin's recommendation of a fan, which is going to be part of round 3. We also talked about the fact that the 5 micron confectioner's sugar seems to have worked spectacularly. We talked about ground chuck, not the hamburger, and hopefully Bart said he couldn't be here today, so he was going to watch the video, and hopefully he and maybe some of you will get something out of that. And we talked about chromoflatosity, and there you go. So I'm not seeing any questions fly in, so I think we're going to wrap it so we don't go too late. But yeah, thanks for being here, guys. I'm glad we are able to maybe contribute a little bit to the knowledge. And that's it. So I'm going to go have lunch, a late lunch, and I'm going to hit the grinder, and we'll talk later. Hey, Robin, I want to talk to you. Thank you, Kevin. Thank you, Carl. Thank you, Wes, K-Bonk, Brian. You guys are awesome. Thanks for being here. We'll see you guys next week. Don't forget the contest. Ciao for now.